a string into the maximum number of unique substrings. So in this question, we are giving a string s, and we're going to return the maximum number of unique substrings that the given string can be split into. So let's just use the first example to understand it. Yeah, so we need to split it into several parts, but all of them has to be unique. So for example, we're gonna split it into something like this example: AB, here AB and C and CC, and all of them are unique. Of course, we can split it in another way, like this A and this A, but that is a duplicate, so we will ignore this kind of testing case. So the length of the array gonna be 5, so we're gonna return 5. So before solving this problem, let's just check if we can solve it by using the brute force. So here, the brute force which I mean is backtracking. So let's just check that. Because the length of the string is only 16, so this means we can solve it by using backtracking. Yeah, so the idea is also the basic case of backtracking. So for example, we have AB, and C. So we're gonna have different cases, but basically the backtracking is a brute force. So we can choose this A, and what left behind is just this areas, or we can choose this B, and what left behind is this areas. So for the next, maybe AB is valid, so we're gonna choose AB, and the next area is gonna be those last 3 letters. Yeah. So we have 3 different cases, and then for this C, maybe we're gonna choose a C. So for left behind is C and C. So CC is gonna be the last case, because definitely we cannot choose a single C and another single C. It is not possible. So in total, that's going to be 5. But this is only one of the possible cases, but this is the maximum length, which is going to be 5. So we're going to return 5. For other cases, maybe it is shorter. So for example, if we make CCC to be only 1, so we have A, B, AB, and CCC only 1. So how many parts? It's going to be 4 unique parts, but we need to calculate the maximum splitting. So it's going to be 5. So let's just start coding for this backtracking problem. So I'm gonna write a backtracking, maybe backtrack. So inside I'm gonna have this string, and I'm gonna have a result array. I'm gonna give a pass at the moment. So what I'm gonna do, I'm gonna prepare a self.result which is gonna be 0, and then I'm gonna call the backtrack, which is gonna be this string and an empty array. And after that, I'm gonna return the self.result. So my testing case, my else case is that it's not string. This means if the string is empty, what are we gonna do? We're gonna check if length of the result, so the result is gonna be an array equal to length of the set of the result. So this means it's gonna we're gonna have a possible answer. So self.result gonna equal to the maximum of self.result with the length of the result, of course, and we're gonna give a return just to let the backtracking run quickly. If we find the answer, we're gonna have a return, and we're gonna try to find another answer quickly. So this is why we're gonna have a return. Now what are we gonna do? We're gonna check all the different cases. So we're gonna use a for loop. So for I in range, let's just use I, maybe. So for I in range the length of the string, we're gonna run the backtracking. So from here, we're gonna check this string. So the string is gonna be I plus 1, because for example, if we take the first character A, so this I is gonna be 0. So for the next character, it's gonna be I plus 1. It's gonna be starting from this B. Yeah. If we take this character, so what left behind is just we need to put it inside of a result array. So we're gonna put something before I plus 1. So because from here it is I plus 1, so from here we need to take something before I plus 1. So it's gonna be like this. Yeah. So this means from here we're gonna take this character A, and what left behind is from this B to the end. Yeah. I think that's all about it. but before running the code, let me have a quickly check if everything is okay. Let me make it better. Maybe like this. This looks better, or no? Yeah, let's make it like this. So if we take it from I plus 1 to the end, so this means we need to take something before I plus 1 into the result array. So this is starting from I plus 1, and this is everything before I plus 1. Yeah. Now let me just run it. As you can see, it works. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases, and it's pretty fast. So because this is a backtracking problem, so for analyzing the time complexity, we need to check basically what's going to be the maximum possible of splittings. Yeah, so from here, like the maximum length is going to be, let me use this example. So the maximum length is going to be 16. So how many splitting areas? So if there are 16 characters, basically we're gonna have, we're gonna start from here. So we're gonna have from the beginning, we can split it like this. This means basically there's no splitting, or we can split it like this. Yeah. So in total, it's gonna be 16 different splitting areas. But for each of the splitting, we can choose to split it or not split it. So it means the time complexity gonna be 2 to the power of 16. 16 going to be length of the string, 2 to the power of n. But here is a for loop. For this for loop, it's going to be n. Yeah. So the time complexity is going to be n times 2 to the power of n. I think that's going to be the final time complexity for the problem. I think that's all about it. Thanks for watching. See you next time.